again?
Yeah, polar molecules means the center of non-polar means if the center of mass of positive coincides with the center of mass of the negative, then that is said to be non-polar molecules. And when you place this type of molecules in the when you place this type of molecules in the electric field, then there is no electric dipole moment. Means the dipole will not align in the direction of the field. Okay.
Yes, sir.
The second one is the second one is that is polar molecules. In polar molecules, what will happen? Example for non-polar is like diatomic molecules, H2, O2, N2, the such type of molecules. When you place such type of molecules in the electric field, there is no dipole moment. Whereas when you come to non-polar molecules, example like we have HCl and all, when you place this type of molecules in the electric field, the dipoles will align in the direction of the field. And there is a net dipole moment in such situation. Okay, so this is about the dipole. This is about the dipole moment. Next one, that gives rise to dielectric concept of dielectrics. Now, what are the six different properties of or electrostatics of a conductor? There are 6 points. What are they?
They are always normal to the surface.
Yeah.
They do not intersect each other.
No, not about that. Electrostatics of a conductor. Yesterday we discussed 6 points, right?
Yes, sir.
One is the electrostatic potential is constant. The first one is interior of a conductor. No, there is no electric
charge and electric field.
Why there is no electric field? Because charge is equal to 0. Okay. Why there is no electric field? Because the charge is 0. The second one is at the surface of a charged conductor, electrostatic field must be normal to the surface at every point. Okay. The electric field should be normal to the surface. And what is the explanation they are given? If it is not normal to the surface, if the electric field is not normal to the surface, what will happen? The electric field will exert a force. It will exert a force on the charge, and the charge will displace from one point to another point. But in static situation, that such thing will not happen. Third one is the interior of a conductor can have no excess charge in the static situation. So even though if you are charging a body, the maximum it can hold. After that, there will be a spark, but they don't go inside the body or inside the conductor. And electrostatic potential is constant throughout the surface, throughout the volume, from the center to the surface it is same, and from the surface it keeps on decreasing. Next is electric field at the surface of a charged conductor is given by E is equal to sigma by epsilon 0. The last one is what electrostatic shielding, effect. Shielding effect means there is a shell inside, inside there is no electric field. Why? Because there are charges 0. On the surface it is maximum. So then what happens? That is about one of electrostatic shielding. Next is what dielectric and polarization that we have seen. Next one is the capacitors and capacitance. Okay. Now, so we'll start with that capacitors and all that concept. Capacitors and capacitance. Now in this one we have, see here there are two bodies. There are two bodies here. One is the positive charge, the other is negative charge. Plus Q and minus Q. And here the potential of this is V1 and the potential of this is V2. This is conductor 1 and the second one is conductor 1 and conductor 2. Okay. Okay. Just a minute, I'm getting it. Sorry, I got it just. Okay, so here, see in capacitors and capacitance, there are two bodies, conductor 1 and conductor 2. Then this is a body with positive charge and this body is with negative charge. And the potential at this point is V1 and the potential at this point is V2. Now, the total charge, so here we write here Q1, comma, Q2 are charges. Okay, Q1, comma, Q2 are charges, and V1, comma, V2 are potential difference. V1, comma, V2 are potential difference. So here we have plus Q and minus Q. Plus here, Q1 I am taking as plus Q, and Q2 I am taking as minus Q. Q2 is minus Q. So we have potential here, V is equal to what? V1 minus V2. So here the total charge is what? The total charge is 0 here. So here what will happen? See, the more the charge, more will be, see here the charges are like this. Here this is negative charge. Okay, so here more the charge, more will be the potential. Is that clear? More the charge, more is the potential. So we are writing here Q is directly proportional to V. To remove the proportionality constant, I am writing here Q is equal to CV. Q is equal to C. This is the formula. Or we can write C is equal to what? Q by V. Clear? C is equal to Q by V. And units of capacitance is what? Units of capacitance is farads. Okay, it is farad. Or we can write coulomb per volt. Okay, is it clear? So it is farad or coulomb per volt. And fixed. We have two types of capacitor here. We have fixed capacitor and variable capacitor. When I speak about fixed capacitor, it is like this. Symbol is like this. And for variable capacitor, the symbol is in this way. So where do we use variable capacitor? See, fixed capacitor, variable capacitor we use in almost all the electronic devices. Variable capacitor is used in tuning of the radio. You know, when you tune the radio, like there is a old radios. If you see, there is one is for channel setting. The second one is tuning the radio. For tuning the radio, we have variable capacitance. Now, when I speak about large capacitor, large capacitor means what? Large capacitor means large capacitor can store large amount of charge. Okay, large amount of charge. Okay, large capacitor means it can store large amount of charge. So now here you know, between the two capacitors, like suppose when we are taking a plate, two plates, these are the two plates of a capacitor. This is the positive plate and this is the negative plate. So what happens? There is an electric field between the electric field between the positive plate and negative plate. Okay, this medium, the medium between the two plates is maybe air medium. There is an air medium between both the plates. So this air medium is also having a capacity to hold certain electric field. Okay, every medium has limit to hold the electric field. You cannot keep on adding the charges. The more the charge, more will be the electric. It doesn't mean that the electric air medium can hold whatever the electric field it can. It's not like that. Every medium is having a capability or capacity to hold electric lines of forces. Okay, may suppose there is a road. There may be a 2-lane road, 3-lane road. Okay, maybe a 10-lane road max. Okay, that many lines can flow. If you are adding some more, there will be a traffic jam. Is it not? If you want to add some more vehicles, no, I don't want on 10-lane road, I want to run 20 vehicles. It's not possible. Is it not? It's not possible. The same way. So what will happen in such situation? There is a spark in between the two plates. Okay, so that is said to be what? A dielectric field. That strength of the medium is known as dielectric strength. Okay, so I'll write the definition for that, dielectric strength. Did you understand the concept here, all of you? Is it clear?
Yes, sir.
Yeah. So I'm writing the definition for dielectric strength. The maximum electric field that a dielectric medium can withstand. The maximum electric field that a dielectric medium can withstand. That a dielectric field can withstand. Dielectric field can withstand without breakdown is called without breakdown is called the okay, without breakdown, that is known as dielectric field strength. So for air medium it is how much? For air, it is 3 into 10 to the power of 6. For A, it is 3 into 10 to the power of 6 volt per meter. Volt per meter is an electric field. It is about the electric field. Okay. Means the meaning is what? If there are two plates and the distance between them is 1 meter. Example, 1 meter. Okay. If the distance between them is 1 meter and the voltage is how much? And the voltage here is 3 into 10 to the power of 6 volts. Then that is the maximum it can hold. So if you are increasing the voltage beyond that, automatically what will happen? There will be a spark in the field. Maybe sometimes you might have seen some sparks between the electrical or electronic circuits. Okay. So this is what happens. You know, long time back there was an issue in Nokia phones. Maybe not now, in 2011 or 2000, I think 2011 or 12, somewhere around. So when the Nokia phones used to explode in the batteries, when you keep it for charging, the batteries used to explode. There was a number called BL5C. So they have replaced all the batteries for replaced for free of cost. Even in Samsung also, in I think Samsung tablet or Samsung, I don't know, notepad something. The same situation happened. They replaced the batteries. So the one second. So the batteries exploded. So what happened is they replaced the batteries. Okay. Because maybe the dielectric field strength or the dielectric strength of the material did not hold that much capacity of the capacitor. Got it? They wanted to increase the capacity of the capacitor, or they want to increase the strength of the battery, but did not work out. So that is why it was replaced. Okay. Okay. Please note down this one. Then we can go ahead. Is it clear? Any doubt in this? Any doubt in this?
No, sir.
Okay. Here. See, 1 microfarad is equal to 10 to the power of minus 6 farads. Okay. And 1 nanofarad is how much? 10 to the power of
minus 9.
What happened? What happened? Moksha, Dhruti. 1 nanofarad, how much?
Minus 9.
Minus 9. And pico? Pico, how much?
12.
Minus 12.
This is the situation now. Okay. Now, so next concept is parallel plate capacitor. In parallel plate capacitor, what we have two plates like this. Now, in parallel plate capacitor, this is plate 1, this is plate 2. This region is first region, this is second region, and this is the third region. Now we have positive plate here. This is the positive plate, and this is the negative plate. Now electric lines of forces, they go down like this. These are the electric lines of forces. Okay. Now this is what sigma is what? Surface charge density. Sigma is surface charge density. This is also what? This is again the same surface charge density, but negative. This is positive sigma. This is negative sigma. Surface. What is surface? What is the definition of surface charge density? Can anyone say? What is the definition of surface charge density? Yes. Surface charge density, charge per unit surface area. Okay, charge per unit area is said to be surface charge density. What happened? Now plate 1, we have sigma is equal to, first we'll start with plate 1. So plate 1, sigma is equal to what? Q by A, surface charge per unit area. Again, plate 2 is also same. That is equal to charge per unit area. Okay, plate 1 and plate 2 is same. But one is positive, the other is negative because minus Q here. Okay, minus sigma and plus sigma. Now we are going to discuss about the outer region. See, outer region of 1. Outer region of 1 is 1. Outer region of 2 is 2. And in between the region like 3. Okay. So outer region 1, region above the plate 1. So we'll start with this outer region, that is Roman number 1. In that case, what happens? E is equal to what? E is equal to sigma by 2 epsilon 0 minus sigma by 2 epsilon 0, which is equal to 0. Why it is so? See, sigma by 2 epsilon 0, from where this came? It came from the infinitely long conducting sheet. Infinitely long, uniformly conducting sheet. From there we got sigma by 2 epsilon 0. Minus also we got from there. One positive for the positive surface we got this. For the negative thing we got minus negative. So that became 0. Okay. The same thing happens in the outer region 3 also. Outer region 2, in that region also electric field will be equal to 0. Why? Because sigma by 2 epsilon 0 minus sigma by 2 epsilon 0. Why again one is positive, one is negative? Suppose if you take this as here, if you take this as one is positive, the other is negative. Positive, negative will cancel out each other. So next one is inner region between plate 1 and 2. Inner region between plate 1 and 2. Plate 1 and 2. So what happens here? That will become E is equal to sigma by 2 epsilon 0 plus sigma by 2 epsilon 0. That will become what? 2 sigma by 2 epsilon 0. So what happens? This and this will go away. E is equal to sigma by epsilon 0. Okay. E is equal to sigma by epsilon. This is the formula. But what is sigma again? See, we already know that sigma is equal to Q by A. Q by A epsilon 0. Is it clear? We know that sigma is what? Sigma is equal to Q by A. Here, sigma is equal to Q by A. This is the formula. From where we got A. Now, see, first, what is the way? First, find out electric field, then go for potential difference, V. Then last, go for capacitance. So, what is the relation between... So in this case, one more thing, D is here. D square is much less than capital A. Okay. The distance between the two plates is much less than the A. And we have the relation between V and E. Yesterday we did. What is the relation between V and E? Anyone? Relation between the electric field and the potential. Anyone? V and E. V is equal to ED, right? Oh my God. V is equal to ED, is it not? So we write here V is equal to what? Q by A epsilon 0 into D. Okay, we got this is the first equation, this is the second equation. Now we have C is equal to Q by V, right? We have C is equal to Q by V. What is that? Third one, C is equal to Q by V. Just substitute here C is equal to Q into D by A epsilon 0. Okay. So this and this will go away. C is equal to epsilon naught A by D. This is the formula for capacitance. Okay. C is equal to epsilon naught A by D. So what is epsilon 0? Epsilon 0 is the permittivity of free space. 8.85 into 10 to the power of minus 12 Coulomb square per Newton meter square. This is the value. So this is the formula. What is area A? A is the area of the plate. Area of cross section of plate. What is D? D is the distance between the two plates. Here this is D, small d. A is the area. D is the distance between two plates. Distance between two plates. That is small d. Is it clear? See once again from the beginning, parallel plate capacitor. There are two plates, positive plate, negative plate, 1 and 2. And the regions are 1, 2, and 3. This is positive and this is negative. This is sigma is what? Surface charge density positive and surface charge density negative. Plate 1 is sigma by QA, sigma is equal to Q by A. Plate 2 minus, that is minus Q by A. Outer region 1, outer region 2. So outer region 1 is cancelled out. Why? Positive and negative will cancel out. Here also positive and negative will cancel out. Only between them there is electric field. So that is also from positive plate to negative plate. So just add both of them, we get sigma by epsilon 0. After that, we have E is equal to what? Sigma is Q by A. Then we know that D square is much less than A. See, there is a fringing of lines or bending of lines. Okay, when you see the electric lines of, that is this one, the electric lines of forces will be like this from positive. So that is said to be fringing or bending of lines. Fringing or bending of lines. Bending of field lines. Okay. Now, so we have D is much less than capital A. That happens because of the distance. Okay, the less the distance, more fringing will take place. So V is equal to ED. Just substitute E there. Then C is equal to Q by V. Substitute there. We get the formula epsilon naught A by D. Okay. Is it clear, all of you?
Yes,
Yes,
sir.
sir.
Now here, if suppose you try this question, if area equal to 1 square meter, if area equal to 1 square meter and D is equal to how much? D is equal to 1 square millimeter. Then can you calculate the capacitance of the capacity of the capacitor? So how much is C is equal to epsilon naught A by D, right? Now, so what happens? C is equal to 8.85 into 10 to the power of minus 12 into 1 divided by D square. 1 square millimeter means 10 to the power of minus 6. So that will become 8.85 into 10 to the power of minus 6
minus 6
farads. Or we can write 8.85